choice exam paper. So let's have a look at part one. There are two parts. Part one is 30 questions, no calculators allowed. And part two is 15 questions with calculators allowed. So let's do part one, going straight into question number one, right? So we want to find the integral of this. Do you know how to find the integral of this? Remember, no calculators.
Yeah, simply. So it will become like x to the power 4 minus x squared divided by 2, substituting the 1 and 2, 2 and 1, so it will look like is it 16? Yeah, 16
Yes.
minus 2 minus 2
Yes.
and minus 1, yeah, 1 minus 1 over 2.
Yes. So the only answers that has like a fraction is A. So anyways, we can work this out. This is 14 minus a half. So that's 13 and a half, which is 27 over 2. Great. Next one. Let f be a function defined by f of x. At which of the following values of x does f attain a local minimum? When they say local minimum, it's the same thing as saying relative minimum. And you need to find the derivative equal to 0. Right, so let's find it. Let's try to calculate it. Yeah, basically critical values. So let's find f prime x. 3x squared. Come, do it.
Minus 9x minus 9.
No. 3x squared
6x.
minus 6x.
6x. Yeah, 6x, yeah. Minus 9.
Divide everything by 3. So you'll get x squared minus
2x minus 3. So we have positive 1 and negative 3. Positive 1 and negative 3. The
positive 1 and negative 3. But if you're looking for critical value, we want to find the maximum.
X minus 3, yeah. Sorry, my bad.
X minus 3.
My bad, yeah.
That's right. 1 second. Remember, if you want to find a local minimum, then you need to put these values on the critical number line. We shouldn't be equating it to 0. We should actually just say find the derivative and keep it like this. Keep it with a 3 outside, with a 3 there. They didn't ask for critical values. Attain a local minimum. When you get a minimum you get when the function increases and decreases. That's a max, from positive to negative, and you get a minimum when it decreases. Then it increases. Negative to positive is a minimum. All right. So that's what we are looking at. So we will put this on the number line, -1 and 3. If you substitute any value less than -1 in this derivative function, we want to figure out whether it's positive or negative. Less than -1, just say -10. So negative and negative, that makes positive. Because these are linear factors, you can alternate the sign, but let's just check. Substitute 0, you get negative, and substitute 10, you get positive, any value after 3. So you can see the minimum is when the function is decreasing, then increasing. The plus and the minus means for the function f, the plus and the minus means increase and the decrease. The minus means decrease, the plus means increase. And over here is increasing and decreasing. We want to find a minimum. So the minimum will occur at x is equal to 3. Are we good? So the answer is A there. Make sense?
Yeah, makes sense, sir.
This is max at x is equal to -1 and minimum at x is equal to 3. Now, if you remember the cubic function, the value of a is positive. So your graph goes like this. Right. So obviously the maximum will be the starting x value and the minimum will be the higher x value. So you see, I did it 2 ways. But obviously you don't need to know whether the what's the shape of the graph and stuff for this part. You just need to draw the number line and work out your answer. Next one, we want to find the derivative of this function. So remember, just basic rule, ddx, just remember this rule here, ddx of root x is 1 over 2 root x. If you can remember this, it's a shorthand thing to remember. It helps a lot. Okay, instead of converting it to x to the power half and then minusing half, is better to, remember this, the derivative of square root of x is 1 over 2 root x. Anyways, let's find the derivative of this. So we will apply chain rule. 2 times 2 is 4, right? Sine root x, take
The
away
power
1
one.
from the power,
Yeah.
right?
Just power one.
Derivative of the inside, derivative of sine is cos root x, and then the derivative of root x is 1 over 2 root x. You can see 4 divided by 2 is 2 on top. You need to have a sine root x, you need to have a cos root x, and a root x in the denominator. So that's the answer D. All right? Easy. Let's move on to question 4. The position of a particle is given by the parametric equation. What is the velocity vector at t equals 1? Easy. Velocity vector, this is a position vector. You're going to find derivative evaluated at 1, derivative evaluated at 1. So what's x prime t? The derivative of ln falls out.
Over t squared plus 1.
Excellent. And evaluated at t is equal to 1 gives us
2 over 2.
2, which is 1. So the answer obviously can't be C and D. Good. Let's work out y prime t. Derivative of e to the power t is e to the power 3 minus t. And find the derivative of the top, you'll get negative 1. And we're evaluating that at t is equal to 1. So you'll get e to the power e squared, negative e squared, right?
Yes.
Yeah.
Negative e squared. So the answer is B. Great. What's up, guys?
Yes, easy.
Right. Question 5. We want to basically, okay, so when they say is, sigma of this is equal to what? So let's say you have to expand first few terms to check what the pattern is like. So if I put e to the power 1 over pi to the power 1, so you get e over pi, you get e squared over pi squared plus e cubed over pi cubed.
So geometric sequence, sir.
Very good, excellent. Geometric series, and you have infinite sum. So sum to infinity is equal to a over 1 minus r. What's the value of a? E over pi divided by 1 minus, what's the common ratio? E times e is e squared, pi times pi is pi squared, or you can take e squared over pi squared divided by e over pi, you'll get e over pi. Good. So now that's e over pi divided by, that's 1 over 1, so pi at the bottom, pi minus e. Right. And then you're going to simplify e over pi multiplied by pi over pi minus e. Pi is cancelled out, e over pi minus e. Okay? B.
Nice.
Right. That's nice. Let's look at the next one. The table above gives the values of twice differentiable function f and g and the derivatives evaluated at x is equal to 2. If h is the function defined by, so this is a function that you need to focus on. What is h prime 2? First, we need to find what is h prime x. So h prime x is equal to what? What will we going to use?
Quotient rule.
Quotient rule, good. Differentiate the top, f double prime, leave the bottom, g.
Minus,
Subtract, differentiate the bottom, g
G prime.
F prime over g squared, and is all evaluated at x is equal to 2. So what is f double prime 2? 3.
3. Nice.
3. Was g of 2? G of 2, negative 2. Was g prime 2?
5.
5. Was f prime 2? Negative 3.
No, 3, negative 3. Yeah.
Over g squared, what is g? Negative 2 squared.
So 4.
Right.
Yeah.
So let's see, what do you have on top?
Negative 6
plus 15.
Yeah, plus 15, nice. Divided by 4.
Over 4. 9 over 4.
Which is 3 over 2.
No.
Yeah, sorry. Yeah.
Just 9 over 4. Right. No, just be careful. No calculators. Square rooting. Okay.
Yeah, my bad.
Oh, this is the part in the exam where we don't use calculators.
Yeah, no calculators, yes. Right.
Okay.
Which of the following is the Maclaurin series for x cos x squared? Now remember, there are some types of Maclaurin series which you got to memorize, okay? And when I did Taylor and Maclaurin series, if I go back to the lesson, see, these are some of the things that you need to, I forgot to highlight these, but these are some of the Taylor and Maclaurin series. These are the Maclaurin series that you need to memorize: sin x, cos x, especially those ones. Don't know, I haven't seen a question with tan inverse. I haven't seen these, but don't even worry about the last one. Yeah, you got to memorize this. It's easy. Sin x is -1 to the power n, x to the power odd over odd factorial. Cos is -1 to the power n, x to the power even over even
yeah.
factorial. That's it. So just remember, cos is even. So let's go back. So what is cos x?
Even, so yeah.
Yeah, cos x is alternating series, right? So -1 to the power n, x to the power even, which is 2n over 2n factorial, and n equals 0 to infinity. So expand cos x. It's going to be -1 to the power 0, x to the power 0 over 0 factorial. So 1 minus is alternating signs. When you substitute 1, you get x squared over 2 factorial. When you substitute 2, is positive, -1 squared is positive. Whenever you have -1 to the power n, it's alternating signs. So first one started positive, then it's negative, then it's positive, then it's negative. So what's the next one? X to the power 4 over 4 factorial plus ... What is this? This is cos x. So what is cos x squared? We just need to replace the x with the x squared. So 1 minus, if you replace the x with the x squared squared is x to the power 4 over 2 factorial plus x to the power 8, isn't?
8,
over,
okay.
Over 4 factorial. That's not changing. Yeah. Plus ... Now you just need to multiply this everything by x. So if you multiply everything by x, I multiplied this side by x, so I must multiply this side by x. So x minus x to the power 5 over 2 factorial. Why did I put 2 factorial? Yeah, 2 factorial. Because 2 times 1. Plus
x to the 9.
Yeah,
over
so
4
8
factorial.
answers A, yeah.
Yeah, you saw how easy it was.
So
Because you needed to memorize the general form of cos x squared. So remember, cos is -1 to the power n, x to the power even over even factorial. Sine is odd. So if you go back to Taylor and Maclaurin series.
So it's still an alternating sign, yeah?
Yeah, it's still alternating series. Okay, you can see how the series expand. So remember sine and cos. Okay, you got to remember you got to remember 1 over 1 minus. That's a normal geometric series. That's easy to memorize. That's also, you got to memorize the basic ones. I feel these are the basic ones. Don't worry about tan inverse. I haven't seen that. Ln 1 plus x is easy to memorize that as well. So just those ones that I highlighted and those two as well. So just remember, you can go back to lesson number 47 and see.
When it comes to Taylor and Maclaurin, it's basically just memorization.
Yeah. So for Maclaurin series, especially for these ones, Maclaurin series. For Maclaurin series, you gotta remember the general forms, general expansion for sin x, cos x, and then replace the variables and solve. It's just nothing was difficult here, right?
But Taylor series is still one thing, yeah?
Listen, I wanted to ask you a question. Can we check this answer against some form of substitution? Like if I substitute, look at everything is starting with the x. What is the known thing that you know? You know that cos of what you say, cos of 0, you know, is 1.
Is
So I don't think it's going to help us here. Maybe cos of pi by 4, but now you see you got x squared here. That's the only problem. And no calculators allowed. I was thinking of substituting some values to check which one works. You see?
Oh,
Yeah.
This one is a long way, by the way, so no?
Yeah. That is a long way.
Well, since it's x cosine x squared, you know that it's either going to be a or b because they both start with x.
No, what about this one here? Is x cubed, x cubed. Why can't you just start with x cubed?
Because it starts with 1, the cosine x function.
Yeah. Of course. Even the sin x also starts with 1. No, sin x starts with the x. Sin x starts with the x, yeah.
Oh, so Mr. If it was, for example, x squared sine x, then it would start with 3. Oh, sorry, it would start with x cubed.
Oh, they checking the knowledge of memorization, Ustad. You see
Yes,
that?
yeah. So,
Yeah.
So
This is
what
a
percent of
trick.
the exam is Taylor-Maclaurin series and geometric series and all that?
no, there's not so much. It's just like very few percent. They'll only ask you one question. See, they
Yeah,
only
but
ask you a
you are
single
MCQ.
question in the McLaurin series, in multiple choice.
Okay,
Right, let's
let's
have-
go on.
All right, let's move on to this next question. All right, so what is
Infinity
this?
over infinity, yeah.
Right, so infinity over infinity. So L'Hopital's rule, differentiate the top minus
Differentiate.
12x. Yeah, minus 12x over 3e
3x
to the power.
dx.
Yes, yeah.
Right, again infinity over infinity.
So negative 12 over infinity, which is 0.
Yeah.
3e to
What's
the
gonna be diversion?
power.
No.
No, wait,
One
one second. 1 second. So negative 12 over infinity is going to be 0. Good.
Yeah.
So that approaches 0 as x approaches infinity. Okay, anyways, quite easy, right? Let's move on to the next one. A function f is not differentiable at x is equal to 5. Now, what does differentiable mean? Differentiable means that the derivative exists. So let's write down the definition of the derivative. F prime x is equal to limit. Okay, let me add the limit later, right? What if I say f of x plus h, f of x plus h minus f of x divided by x plus h minus x. That's how you get all over h. But now if I say limit as h approaches 0, okay. Now, remember, they're already telling us that it's not differentiable at x is equal to 5. Let's substitute 5 here. So f prime x is equal to limit
Oh, f of
as
x minus f of x.
no, it's going to be 5 plus h.
Yes,
F of 5
minus f of 5.
minus f of 5 divided by 5 plus h minus 5. Just let me hold it on to that like this. See what they have over here. So obviously you need something in this form to check differentiability. So this is differentiable. If I do something like this, it is differentiable, right? Limit as h approaches 0. So now how do I transform this into looking like option number C? Like, why say it's not differentiable? Because if I substitute 5 in the denominator, what it becomes? Yeah, it becomes 0. So that's the reason why it's not differentiable. So now let's see. So let's check how can I transform this into that. So obviously we need to say let x be equal to 5 plus h, right? As h approaches 0. See, I'm changing the limit as well because I'm using a kind of u substitution. As h approaches 0. So if h is 0, x approaches 5. So that becomes limit as x approaches 5. Okay. What is this? What is 5 plus h? That's f of x minus f of 5 will remain, that's just a constant, divided by what's 5 plus h? X minus 5. So there's it here. Okay, so it's not differentiable. So it's not differentiable at 5. You can't evaluate
So not
this.
exist.
Yeah, so limit does not exist. That's what it means. If it's not differentiable, then the limit does not exist. Correct. So the answer is C in this case. So just remember, what's the rule for differentiability? So obviously you can't choose an integral. The integral doesn't mean anything. You can't say f is not continuous at x is equal to 5, right? Because you can get a function which is not differentiable, but it is continuous, like an absolute value function. Say absolute value function is like this, absolute value of x. It is continuous at 0, but not differentiable at 0. So this is nonsense, all right? Remember, P implies Q. If it is differentiable, then it's continuous. And this is identical to not Q. If it's not continuous, then it's not differentiable. It has to go in that not Q implies not P. So if it's not continuous, then it's not differentiable. Okay. You can't say if f is not differentiable, then it's not continuous. It doesn't imply that. So that's also nonsense. Does not exist. Limit as x approaches 5 of f of x. This here got nothing to do with differentiability. There is no derivatives there, right? Yeah, and we said this is nothing. So that's only your correct option. Are we good? Makes sense, guys?
Yeah, makes sense. So yeah.
Right, let's move on to the next question. Right, the second derivative of the function is given by this. At which of the following values of x does the graph have a point of inflection? You can try answering this question here. And I
I
will
think
guide you.
we should, by the fundamental theorem of calculus, we should integrate, yeah, for taking
No.
f prime.
What is point of inflection? Point of inflection you find by finding double derivative. Okay, they already gave us the double
Oh,
derivative,
yeah.
right? They already gave us the double derivative. Now, how will we find the point of inflection? Point of inflection is when the graph moves from concave down to concave up.
Yeah,
That's
so make
inflection
equal to
point.
0, yeah.
And even this one here, concave up to concave down to concave up, or concave down to concave up to concave down, if the graph moves in that pattern. Now, the point where it changes concavity, what is inflection point is very important definition. Not making the double derivative equal to 0. Inflection point is a change in concavity. All right, making double derivative equal to 0, you're going to end up with 0, 3, and 10. You're going to select this answer. But remember what I said, the point of inflection is a change in concavity. So when will the concavity change? You need to put all these on the critical number lines, 0, 3, and 10. Choose any value after 10. Let's choose 100, so that'll give us positive. Choose a value between 3 and 10, like 4. 4 minus 10 squared, positive. 4 minus positive again. So it's concave up, between 0 and 3. Choose a value like 1. That's positive. So this is 1, and negative, that's negative. Any value less than 0, negative 10, negative, negative, and positive. So positive. So this is concave up, this is concave down, and this is concave up. So where's the inflection point? At 0,
0
and 3 only. You can't go at 10 because there is no change in concavity. This is also concave up. There is no change in concavity. So the answer is B. Are we good, guys? Right, excellent.
Yeah, okay.
Right, so what's inflection point? Change in concavity. So be careful. Many students can choose this answer, which will be wrong because you didn't check for concavity changes.
So Mr. the best way you can handle this is by drawing the number line with 0,
Yes.
3, and 10. The ones that make it 0, and then you
Yes.
experiment with the numbers in between.
Yes. You need to understand the definition of point of inflection. It is change in concavity. Right,
Yeah.
guys. Let's solve this integral. It's from 0 to pi e to the power x minus x, or e to the power x minus 1 over e to the power x minus x.
U substitution.
Good. We'll try u substitution. So we say let u equal to what?
E to the
E
power
to
of
the
x.
x minus x.
Very good. E to the power x minus x. So du is equal to?
E to the x minus 1.
Does e to the power x minus 1 exist in our integral? Yes. E to the power x minus 1 dx is du.
So 1 over u du.
1 over u du. Let's change. What are these values? These are x values. So let's change it to u values. If the x value is 0, e to the power 0 minus 0 is 1. If the x value is pi, you'll have e to the power pi minus pi. So e to the power pi minus pi. Those are the values on the integral. Now, what's the integral of 1 over u? That is just ln absolute value u. And what's my boundaries? From 1 to e to the power pi minus pi. Now, if you substitute e to the power pi minus pi, you'll get ln e to the power pi minus pi. And
So
if you
pi minus
substitute
pi.
1, so if you substitute 1 inside, you're going to get ln of 1, which is 0. So the answer is just ln e to the power pi minus pi, d. Okay? If you substitute the upper boundary inside here, you get ln e to the power pi minus pi, and then you get minus ln 1. Ln of 1 is 0. So that's your answer, D.
Easy.
Okay? All right, easy. Next one. The table above gives selected values for differentiable function f in which of the following intervals there will be a number c such that f prime c is equal to 2. I think we did this in AB. Yeah, it was a repeated question from AB. So you need to find f prime c is equal to 2. So that's basically you're finding the slope. So it's like y2 minus y1 over x2 minus x1. And you need to solve that to be equal to 2. Remember, this is the instantaneous gradient, and the instantaneous gradient must be 2. So where's y2 minus y1 over x2 minus x1 is equal to 2? Between which interval? 0 minus 8 over 4 minus 0, no. 0 minus 8 is negative 2. I'm getting negative 2 here. What about this? 2 minus 0 over 8 minus 4, no, that's giving me half. 10 minus 2 is 8. 8 over 4. So what's the interval? That's the interval between 8 and 12. 8 and 12, C. Right. The next one. Let y be the solution to the differential equation with initial condition f of 0 is equal to 2. What is the approximation for f of negative 0.4? Obtained by using, yeah, listen, to use Euler's method, write down these values, x0, x1, x2. What's the step size here? With two steps of equal length, you're starting at 0 and you're ending at negative 0.4. So what are your step sizes? Negative 0.2, negative 0.4. Okay? You're gonna start with 0 and then you're coming down to negative 0.4 with equal steps. Make sense? So what's y0? Y0 is 2.
2.
Okay. Now the next value that you're going to find here is y evaluated at y1 will be evaluated at negative 0.2. So that's what we need to find here. What is this value? And then you need to find y2 evaluated at negative 0.4, which is f of negative 0.4. So we need to find those two values. Let's go. So now what is your basically what's your Euler's method formula? Your Euler's method formula is yk plus 1 is equal to yk plus h is the step size, and dy dx evaluated at xk yk. So in other words, you're going to start evaluating from 0 and 2. Right? What is your dy dx? The function values, which is your slope. This is basically your slope. Right? So what are we finding now? y1. So if I'm going to find y1 is being evaluated at negative 0.2. F of negative 0.2, which is approximately equal to what's
2.
Y. Remember, this is Y. No. This is Y1, which means K is 0. So what is Y0? YK plus 1.
No, but it's
K
yk
0.
plus 1 is equal to yk, which should be 2. So y1 is equal to 2.
YK. Yeah. That's what I'm saying. 2 plus, what's your step size? Negative 0.2.
Oh, okay.
How do you get the step size? You take the final minus initial, negative 0.4 minus 0 divided by 2. So that's how you get your step size, negative 0.2. That's your h. Okay. Final minus initial x value divided by the number of steps you are using. You are using 2 steps. And I haven't seen any question that says 3 steps and 4 steps. You're always using 2 steps. So just divide by 2. Just read the questions carefully. Now, what is dy dx evaluated at x0, y0? Evaluated at this value. What's the slope evaluate? Obviously, you can't evaluate the slope at this point here because that's what you're trying to find. You have to evaluate the slope at the previous point. So substitute x value as 0 and y value is 0, or y value 2. Substitute 0 and 2 in the slope function, which is x plus 2y. X is 0, 2 times 2 is 4. So 4. Okay? Now, what is the value of this? This value is negative 0.8, 1.6. Okay? So I'm going to write down 1.6 here. Are we good?
Yeah, and by y1 we will find y2. Yeah.
Now we're going to use y2 is equal to f of negative 0.4, which is, that's what we're doing. We're finding y2 evaluated at negative 0.4. Now, When you're evaluating this at negative 0.4, what does the formula say? We need to find, this is y2, right? So what is y1? y1 is 1.6 plus step size is still the same, negative 0.2. Negative 0.2 is the step size. Step size remains the same. Step size is h.
Oh,
You understand?
yeah.
Step size
It's a
needs to
difference.
remain the same. Yeah, it's the difference. The step size is each step. What is the difference between x2 and x1? Still 0.2. Now, we need to evaluate this value over here on the inside. No calculators, right? So you need to evaluate it at the previous point. What is the slope at the previous point? So x is negative 0.2 plus 2 times 1.6, right? Because 2y. 2 times 1.6 is 3.2. Make sense? Are we good?
Yeah.
Right. So we got 1.6 plus negative 0.2 into 3. Make sense? Am I doing this correctly? Just 1 second. Negative 0.2. Yeah, it is right. 2 times 1.6. 2 times 1.6 is 3.2. Yeah, it's right. Okay. Now, negative 0.2 times 3.
Negative
What is it?
0.06.
Yeah, so what is this?
Negative 0.06. Yeah.
Something wrong with that, yeah. There is no answer 1.
There's no answer there. Yeah. No. I think we made a mistake here. Look at here. 2 plus negative 0.2 times. That's where the mistake is. It's 1.2, not 1.6.
Oh.
So that's 1.2. So it's 2 times 1.2 is 2.4, I think. 2.4, yeah. Right? So now you're getting 2.2 here. Yeah. Take the 3 out. Take the 3 out. It's 2. What is 6.6?
2.2 times 3 is 6.6. Oh, no, you're not.
No, wait.
3.
Wait 1 second.
So that's the new number. Yeah.
It's fractions. Wait. Let's do it like this. 1.16 over 10. Let's convert everything to 10. Because even I'm getting confused
no,
now.
teacher. 12 over 10. 12 over 10. We should change our 1.6 to 1.2.
No, yeah, 1.2. Thank you. 1.2. Yes, 1.2. 1.2. Yes, 12 over 10. It's better to convert it like this. 12 out of 10. And that's negative 2 out of 10 times 22 over 10. Okay. So you got 44. So you can make it 120 out of 100 then. Make it out of 100. 120 out of 100. So you basically have 120 minus 44 out of 100. What's the answer?
It's like
76
divided by 100. So 0.076. 0.76. Nice.
So there's your answer. Are we good?
I still don't understand. How did you get 1.2 and y1?
Yeah,
What was the
because
mistake?
yeah, I made a mistake. Yeah, I said 2. I don't know how I had 1.6. 0.2 times 4 is 0.8, and 2 minus 0.8 is 1.2.
Oh, when you were solving for y1.
Yeah. I made a mistake there. I put 1.6 and there was no answer over here. Right. So anyways, that's our answer. Next one. What is the slope of the tangent line? So if you're finding the slope of the tangent line at this point, we have to do implicit differentiation. Okay. And I told you, just remember the derivative of root x is 1 over 2 root x. So what's the derivative of root x? 1 over 2 root x. We're finding derivatives, right? So we're finding derivatives. What's the derivative of root y? 1 over 2 root y times y prime, because y is a function in x. We're doing implicit here. Okay? Make sense?
Okay.
If you try to do implicit here, what you're going to end up with? Watch here. You're going to end up with, if you're going to try to do implicit here, you're going to end up with dx over dx. So that's just 1. If you do implicitly, you're going to end up with dy dx, which is y prime, which is equal to 0. Okay. Now, we want to solve for dy dx, right? So let's try to simplify this. We're going to take this entire thing over to the other side. So 1 over 2 root y times y prime is equal to negative 1 over 2 root x, because I took this term over to the other side. This here cancels out, that's just 1. Right, so take this over to the other side, that's fine. Now, if I try to cross multiply, I will get 2 root x. The 2's will cancel out, okay? Multiplying both sides by 2. So if I take this root y across to the other side, there, problem solved. Take the root x, root y, cross multiply, so you get y prime is equal to root y over root x with a negative. So we get negative, what's y? Y is quarter, okay? So root y be quarter over root x is 9 over 4. Root of quarter is negative half. Root of 9 over 4 is 3 over 2. So multiply by 2/3. So my answer 2 and 2 cancels out.
Negative 1 over
Negative
3,
1/3.
yeah. So B.
Right?
Nice.
Yeah. Next one. We can find the integral of this. Now this integral is improper. You must
we change it
replace
by t,
infinity
yeah?
with t. Yeah. So you say limit as t approaches infinity. Replace this by t. Integral 1 to t. 6 over x plus 3. Let's make x plus 3 equal to u. So du is equal to dx. It has no change. There's nothing there. So that's just x plus, make it u to the power, or make it x plus 3 to the power 3 over 2. It's not going to change anything because there's nothing on the inside. It's just like du equals dx. So keep it like that. Just integrate this like normal. So limit as t approaches infinity. Integrating this like normal. Forget about what's on the inside of the bracket. It'll just be 6 x plus 3 to the power
Positive
negative
1 over
half.
2. Negative half.
Negative.
Sorry, negative half. Yeah.
We're adding 1. Divided
Yeah.
by negative half. Now you can't say plus c because we have values from 1 to t. Limit as t approaches infinity. We're almost done. 6 divided by negative half is 6 divided by negative half is negative 12. Okay. I'm putting t inside. So this whole thing will go to the denominator. It becomes square root of t plus 3. Okay. Does it make sense?
Yeah, makes sense.
6 divided by negative half is negative 12. And remember, this is negative power, so that will go to the denominator, and to the power half means square root inside or outside. Square root t plus 3. Subtract negative 12 over, substitute 1 inside. 1 plus 3 is 4. Square root of 4 is 2. Substitute infinity inside. What's minus 12 over infinity? 0. So what's your answer? Negative 12 over 2. The answer is the second part. Does it make sense?
Yeah, positive 6.
Positive 6. Great. Right, let's look at the next problem. dy dx is equal to 2 minus y. If y equals 1, when x equals 1, then y equals. So this is a differential equation. We need to solve it, right? So we're going to say, take the 2, cross multiply, take the 2 minus y at the bottom of dy, and take the dx across. Integrate both sides, right? Integrating both sides will give you len 2 minus y with a negative outside, okay? Make sense? Why negative outside? Because of the negative inside. If you make u equal to 2 minus y, then you have du is equal to negative dy. Okay? So that's why there's a negative on the outside. So if you're going to convert this integral, let me just do it like this. So if you convert this if you convert the integral on this side to dy, not dy, du over is basically negative du over u is equal to integral of 1 dx is just x plus c. All right. Now, what's the integral of this side? The integral of this side is negative ln u. What is u? 2 minus y. That's why I did it like this. Okay. Is equal to x plus c. Now we need to solve for c. Okay. How are we going to solve for c? We are given 1, 1. X value 1, y value 1. Those are x and y values. We're going to substitute it inside this differential equation and solve this. So we got negative ln 2 minus, so this is just 0. So just 0 is equal to 1 plus c. So this implies the value for c is equal to 1.
Negative.
A negative 1.
Negative 1, yeah.
The value of c is negative 1. Now you need to solve for what? You need to solve for y, right? Easy. So we have, where's the equation? There's the equation. So negative ln 2 minus y is equal to x minus 1. I'm going to multiply both sides by negative. So I'll get 1 minus x. Okay. Now,
Yeah, basically, yeah.
absolute of a minus b is the same thing as saying absolute of b minus a. So I can just say make this y minus 2, right? I'm going to e both sides. Right. So e and ln falls off. Remember what I said? This rule here with the absolute value, I'm going to make it y minus 2 is equal to e to the power 1 minus x. And then take the 2 over, I will add it. So this implies y is equal to e to the power 1 minus x plus 2.
Nice.
Do we have anything? E to the power. We don't have e to the power 1 minus x plus 2. Yeah, but...
Yeah.
Oh, yes. I'll tell you why the answer is like this. Because remember, I dropped the absolute value. I shouldn't have done that. Okay. So the answer can be positive or negative. If I drop the absolute value, then the answer can be positive or negative. Right, so this is one of the answer. If I drop the absolute value, if I don't drop the if I drop the absolute value, there's another negative outside, which is e to the power 1 minus x. If I multiply this side by negative e to the power 1 minus x, y minus 2, take the 2 over. This implies your another answer is 2 minus e to the power 1 minus x. So there's two solutions to this differential equation. This is solution 1. And this is when you drop the absolute value, there's a negative and there's a positive. And this is solution 2. So they were looking for the second solution, 2 minus e to the power 1 minus x. You understand?
Yeah.
Because if I ask you a basic question, solve this equation, absolute value x equals 2, what's the answer? X is equal to 2.
Positive 2, yeah.
Yes, or x is equal to, or negative x is equal to 2. So x is equal to negative 2. So you got two answers. So that's what I'm doing here. I'm not doing anything fancy. I'm just doing stuff that you already know. Right, move on to the next question. Right, so this is a little bit challenging, right? So what they said, which of the following series converges? Which of the following series converges? Now we're going to look for, we're just going to push infinity. We're going to take the absolute, right? Infinity. So we're going to do this test here. What test we're going to do? Absolute AN test, right? And limit as n approaches infinity. Are we good? So
it will divide by an minus 1, yeah? Like this was? Or n plus 1?
No. We're not doing a ratio test. We're just doing infinite test. Infinite absolute test. Okay?
Okay.
Right, so let's test the first series. If I take absolute value of -1, remember these are all an values. Whatever is on the inside is an. If I take absolute value of all this and push infinity inside, so the first one, let me just do the first one long method. So it's going to be limit as n approaches infinity of -1 to the power n, 1 minus n over n. Now, absolute valued, okay? Now, if you're taking absolute valued, absolute value of -1 just cancels out because that's absolute value. That's just 1. So what are we left with? We're left with this. So remember, when you're taking infinite limits with polynomials, you know what to do. You compare the degrees of the exponents. So that's 1 and 1. You can just divide. So the answer is -1 here. And taking the absolute value, you get 1. Right? 1 is clearly not equal to 0. So it diverges. It needs to be equal to 0 to solve the problem, right? So that diverges. Next one.
The same method, so it will be
Same
like
method, half. Oh, no.
yeah.
What do we get? What is this? N and 2n. So divide the top and the bottom by n, highest degree of the denominator. So you get a half, which is clearly not equal to 0. So that also diverges. Okay. Next one.
Yeah. Is n the power of
Infinity, I
2
think.
divided by.
No, we're going to simplify this. So limit as n approaches infinity is n to the power 2 divided by root n. So you'll basically get n root n divided by 3. So if you substitute infinity, you're getting infinity over 3. So that approaches infinity. So that clearly diverges. Okay. And let's see the last one. We got root n over n, right? So limit as n approaches infinity of 2 over root n, correct? If I push infinity here, what are we getting?
0.
We're getting 0. So they ask which one converges.
So it's converges here.
Yeah, so basically this does converge. This is correct, but we need to check other conditions. Let's test the first condition. First, you need to check whether the series is alternating. Yes, good. It's alternating. The second condition that you need to check in these types of problems, to check for convergence, this is all convergent. Every time we do testing for series, we're always checking for convergence, okay? So alternating series, we're checking for convergence here. The next thing that we need to check is limit as n approaches infinity of an. Make sure this happens. Limit as n approaches infinity of absolute of an is equal to 0, okay? And the third thing that we need to check is, now what is this? This is alternating series test. That's what it is. So that's test for alternating series. That's what checking. You can see everything was alternating series. See, everything is -1, -1, -1. That's why it's taking the absolute of an, right? And the third thing that you need to check is terms must be decreasing. Check if the terms are decreasing. How will you know whether the terms are increasing or decreasing? You can just expand the series and check. You know, this part can be written as 2 over root n, okay? So make sure the terms are getting smaller and smaller and smaller. What does that mean? If I substitute n plus 1, say terms decreasing means a n plus 1, right, is basically basically a n. Terms decreasing means, remember you got a1, a2, a3, you got an here and you got an plus 1 here. So basically terms decreasing means an needs to be greater than an plus 1. Okay, so is this true? Let's check. 2 over root n is clearly greater than 2 over the square root of n plus 1. How will we know that? We can substitute n value as known values, like 2 over 1. If the value of n is 1, that's 2 over 1 is 2. And if you substitute n plus 1, right, 2 over root 2, you can clearly see 2 is greater than 2 over root 2. So this here means terms are decreasing. Are we good? So if you check If you check these three conditions, and if it satisfies these three conditions, first, the series must be alternating. Second, the absolute must be 0. Okay. And terms must be decreasing. Then it converges. Then it converges. So now let's check. See, for the first one, we didn't bother checking anything because it wasn't equal to 0. We didn't bother checking, not equal to 0. Only the last one is equal to 0. So we need to check. But it's fine. Because the first three diverges, then you definitely know T can be the answer. So you don't even need to do these tests in the multiple choices. But for written question, you got to do it. Next one. Let R be the region in the first quadrant and second quadrants between the graphs of the polar curves. F theta is equal to 3 plus 3 cos theta. Which polar curve is this? If theta value is, remember sine and cos graph? This is a sine graph. And cos graph starts from 1. Remember the basic cos graph, right? What line is this? 1 second. What line is this? This is a 0 line, and this is pi by 2 line, okay? Which graph is this? Is this graph f theta the inside graph or the outside graph?
No, I think it's inside.
Substitute,
No, out.
Substitute pi by 2. F theta 3 plus 3 cos theta. Substitute pi by 2. What's cos of pi by 2? 0, right?
0, yeah.
So you got 3 times 0 plus 3. So it has to be at pi by 2 is 0. So this is f theta graph. Okay. Next one. G theta is 4 plus 2 cos theta. If I substitute pi by 2, so there at pi by 2, I'm getting 4. So great. G of pi by 2 is 4. So which of the following integral expression gives the area of R? To find the area of R, very easy. Area is equal to half integral a to b of R outer squared minus R inner squared d theta. So you got half. What's a to b? Between some, yeah, where are you integrating from? This entire region R from 0 to pi. Can you see? This is a pi line. You're not going beyond pi. So it's just from 0 to pi by 2 to pi. So you're integrating. Now, what's the R outer? Which one has a bigger radius? Is it F theta or G theta?
Larger radius.
Yeah,
F theta.
is G.
F theta, no?
No,
3.
no. Wow, how is it 3?
Oh, G
It's
theta,
4.
yeah.
G of theta. All right, so G theta, oh, out, which is R out. Remember, R is a function in theta. It's polar coordinates, okay? So R is a function in theta. So we're saying this is in. This is R inner one, and this is the G theta is R outer one.
Is it
So
like
what's
upper function minus like bottom function minus top function?
No,
Top
no.
function minus bottom function.
No, because now if I do this, if I flip the graph, then you're going to get it wrong. It has to be outer minus inner.
Okay.
So G theta is G theta squared minus F theta squared. So where's your answer?
So D1 only.
Yeah, it's only D. I wrote this incorrectly. Suppose you have another bracket here. Make sure you write properly. Okay. Right, so great. D. Next one. Which of the following statements about the series is true? Right. Question 19.
Is the gain geometric series, sir?
No. You can't say it's geometry. It's alternating series.
Alternating, yeah, because of negative
So
1.
so if it's alternating series, we need to check the three conditions. Let's see. The series can be shown to diverge by the comparison with. How can you compare n squared with this 1 over n? Can't compare this with this. Okay, wait, 1 second. We need to check, do some tests here. Let's apply the three conditions. You know the three, because you see, this is 1 over n, this is also 1 over n, this is 1 over n squared. I want to try and fit in three conditions. Can we do a comparison here? Okay, I'm not sure. So let's do the first one. Is the series alternating? I'm checking the three
Yes.
conditions for alternating series. This is an alternating series, so I'm checking the three conditions. So it's an alternating series. Alternating. This is alternating series. The next condition I want to check is limit as n approaches infinity of absolute of an must be equal to 0. Is it? Yes, the degree in the denominator is bigger than the degree on the numerator. Is that correct?
Yeah, it's correct, Ustad, yeah.
Right.
Because
So you can
negative will
see,
become positive because of the absolute
yeah,
value, so it will become like this. Yeah, correct.
yeah. So this is 0. Or you can even use the Peter's rule. You differentiate the top, differentiate the bottom, and then the next step will give you 0. Okay. You're going to get 1 over 2n. And eventually that will become, yeah, so that will become 0. And what's the third one? Let's check if this is decreasing. Okay. We're going to check if the terms are actually decreasing.
It's number 3, Ustad, yeah.
The series can be shown to converge by the comparison of, no, you can't compare with 1 over n squared. Anyway, what they said, when we're checking these, remember this here diverges, this here diverge by comparison. No, it's not diverging by comparison. This is diverging because of 1 over n. 1 over n is what? 1 over n is harmonic.
Oh, yeah,
right?
harmonic, yeah.
That's harmonic, which is p equals 1. This is a p series. Again, series, they're saying limit comparison again. No, it's not limit, it's p series. So harmonic here as well. So both incorrect options, right? Because this is also, it's not limit comparison is wrong. Even this one here. Yeah, it does diverge. It's harmonic, it diverges, but it's not comparison test. We're not doing comparison here. The series can be shown to converge by comparison. If this is equal to 2, it does converge, but are we comparing it with this? No. Let's check if the terms are decreasing, okay? The absolute terms. We want to check if the absolute terms are decreasing. How? Let's say an plus 1. So remember, we're going to say n plus 1. We want to see if an plus 1 is greater than. Let's check if an is greater than an plus 1. Let's check. Then terms are decreasing, okay? What's an? N plus 1. Don't worry about the signs, okay? Over n plus 1 all squared plus 1. No, man. Sorry. Let me say this. Should be n over. An is n over n squared plus n over n squared plus 1 is clearly greater than n plus 1 over n squared plus n plus 1 over what am I writing? N plus 1 squared plus 1. Are we good? Now remember, n can be greater than n is basically equal to 1. That's what we know. Now, how we know that is because of n starts from 1 to infinity. Now, n is an element of integers as well. So how do we go about solving this equation and showing that it's decreasing? How do we show that this is decreasing? I don't know why this is represented. How about showing this, making it equal to f of x and finding the derivative to show whether it is decreasing or increasing? Let's check if this function is decreasing. Change the n to x over x squared plus 1. You can also do this. X over x squared plus 1. Let's check if this is actually decreasing. So f prime x is equal to, this is another way to check for decreasing. Yeah, it is because n plus 1 over n plus 1. You're basically squaring the denominator, you're making the denominator bigger. And you
Which
just
is
have increments of
decreasing,
1.
yeah.
This is decreasing. But anyway, let's show it using this. Derivative of the top is 1, leave the bottom, x squared plus 1. Subtract derivative of the bottom is 2x, leave the top, x all over x squared plus 1 all squared. Now remember, x has to be greater than or equal to 1 because of the same concept there. Now you can clearly say x squared minus 2, x squared minus 2x squared is just negative x squared. You got negative x squared plus 1. 1 second. Differentiated the top is 1, left the bottom. So that's x squared minus 2x squared is negative x squared. Let me put it in this form. Minus 1, put it like this. Over x squared plus 1 all squared. X squared minus 1. Now, don't worry about the bottom because the bottom is always positive. Let's observe the top. I've got minus x squared plus 1. Isn't minus x squared plus 1 is a graph that goes like this? 1. And if I'm starting more than 1, I'm looking at this half of the graph. You can see this graph is just decreasing. So f prime x. So basically f is decreasing. Look, if you don't know how to solve it like this, you can also choose, substitute a large number like 10. Or substitute in the place of n. So 10 over 101. Is that greater than 11 over, what is this? We're saying 10 plus 1, 122. Because that's 121 plus 1. Yes, it is greater. Okay? Because you can see getting 10 out of 101 for the quiz is better than getting 11 out of 122. Isn't? So you can say that the previous terms are basically bigger than the next few terms. So the series can be shown to converge by the alternating. So it satisfies all three conditions. So it's converging by the alternating series test. So that's the answer. Are we good? So the rest of them are all nonsense. You got to test these things. First, make sure it's alternating series. Second, make sure that the limit as is infinity is 0. And third, show that the function itself is decreasing. All right. I showed it by showing that it's a f of x function and it's decreasing after 1. And I showed it by using limit compare. So we're not 1 over n squared. We are comparing this to using alternating. We are doing alternating series test. So these are the three conditions that needs to be satisfied. Anyway, let's continue. If f of x is equal to 1 to 4 is x, g of x is minus 2, which of the following cannot be determined from the information? Find each one. Integral 4 to 1 is the same thing as a negative integral 1 to 4. A negative integral 1 to 4 of g dx is negative 8. Okay? Because they told us 1 to 4. No. G 1 to 4 of g dx is negative 2. So negative 2 will give us positive 2. 3 times f of x. Yes, that's 3 times f of x times this is impossible. This is clearly not equal to 3 f of x. Okay? Plus this. So what you're gonna do? You can't split it up. It's impossible. So that's the one that's impossible to. So remember, when you're doing integral, you can only take integrals into sums and differences. You can't take integrals into division and multiplication. So that's impossible to evaluate. Right, so that's the answer. Cannot be determined. That can be evaluated. Yeah, this one can be determined because this is just a sum. We can only integrate into sums and differences. You can't integrate into products and division. Next one. Which of the following is the interval of convergence for the series? Interval of convergence, now we're talking interval of convergence, we use a ratio test, right? So now we're doing an plus 1 over an, and we take limit as n approaches infinity, right? So this is what's an plus 1? X to the power 4 n plus 1 over, don't worry, I'm going to push limit to infinity just now. N plus 1. 5 to the power n plus 2, right? Dot. You flip and change. 5 to the power n plus 1, n. I'm just writing in different order. X plus 4 to the power n. Now, what are we left with? Let's deal with the x to the power 4. Let's deal with the x to the power 4. So we just left the x to the power 4 on top. The n over n plus 1 I can write there. And I'm left with 5 at the bottom, right? Limit as n approaches infinity. That is just 1. Okay. So what are we left with? Absolute x plus 4 over 5. It needs to be less than 1 for convergence.
So it will become x plus 4 less than 5. So yeah, it's converged. Yeah. Less than 5, yeah.
X plus 4 is less than 5. We drop the absolute value. Minus 5. X plus 4 less than 5. Bring the 4 over. Minus 9 to
And the
1. Minus 9 to 1. It has to be minus 9 to 1. So this is
So
the
we should
only
check.
one. Maybe at the endpoints. You'll check the endpoints in multiple choice. Obviously, it can't be any of these options because it says 1 to 9, minus 5 to 5. Why you want to check endpoints now? It's multiple choice.
Exactly. No
But you
need,
can
yeah.
go. Yeah, no need over here. But remember, you need to check the endpoints because remember, we didn't include it here. The endpoint is included, and which is the first one that is included. Okay. And the reason why it's included because it converges at negative. If you substitute the x value of negative 9, it will converge. Where is it? Negative 9 plus 4, which will give you negative 5 to the power n. Yeah, it will become an alternating series that will converge. What is the slope of the line tangent to the polar curve at the point where theta equals pi by 2? So we have some polar curve r equals 3 theta, right? R equals 3 theta. And we want to find the slope of the line. What is slope of the line? Slope of the line means slope, no, derivative of what? Slope of the line means dy dx. You want to find dy dx.
Yeah.
Now dy dx, x is equal to r cos theta, y is equal to r sine theta. Are we good? And what is r? That's what it is. R is a function in theta. Now, dy d theta is the same thing as dy dx is the same thing as dy d theta over dx d theta. Right, fine. What's the derivative of y? R prime sine theta plus cos theta times r. Makes sense? Are we good?
Yeah, makes sense. So yeah.
Just finding the derivatives, product rule. But I told you r is a function in theta. Now, dx d theta is r prime cos theta. What's r prime? Dr d theta. That's what r prime is. Theta. What's the derivative of cos? Negative sine. Negative sine theta dot beta r. Now, I want you to know, you are evaluating this. You evaluating the slope of the tangent line at the point when theta equals pi by 2. So what is cos of pi by 2? Cos pi by 2
0
is equal to, right? And what's sine of pi by 2?
1.
1. So evaluating everything at pi by 2. So straight away, wherever you have cos, you can take out all the cos. That's out because that's 0. That's out. That's 0. Okay. So what is r prime evaluated what's the derivative? What is r prime? R prime is drd theta. What is drd theta? 3. So what's r prime? 3. What is sine of pi by 2?
1.
1 over negative sine pi by 2 is negative 1. And what is r? R is 3
3.
theta.
3 theta.
What is theta? Theta is pi by 2. So the 3 and the 3 cancels out. So you just have 1 divided by pi by 2, which is negative 2 over pi. Makes sense?
Nice. Yes.
Right. Excellent. Next. The definite integral 0 to 4 of root x is approximated by left Riemann sum, a right Riemann sum, and a trapezoidal sum, each with 4 subintervals of equal width. If L is the value of the left Riemann sum, R is the value of the right Riemann sum, and T is the value of the trapezoidal sum, which of the following inequalities is true? First, draw the graph. It's a square root function, okay? Square root of x. So we are trying to find 0 to 4, 0, 1, 2, 3, 4. Now remember, at 0 it is 0, at 1, what's the value at 1? The value at 1 is root 1, which is 1. I'm approximating. Value at 2 is root 2. Value at 3 is root 3. Value at 4 is 2. Makes sense? Now, if I use the left Riemann sum, I'm basically under approximating because I'm going to take that one, that one, that one, and the last one. I'm going to take 4 rectangles, which is nothing here. Then 1, 2, 3. Are we good? Left Riemann sum. So left Riemann sum will give me the smallest value. Are we good?
Yeah, I got you. Yeah.
Now, if I use the right Riemann sum,
Mr. Ghazali, I can't hear you. I think some network problems.
yes, fine. Okay. So with the right Riemann sum, I'm over approximating. So the right will go there. So we know the left is at the right at the bottom. Now, what is a trapezoidal sum? Trapezoidal sum is basically left plus right divided by 2. Okay. So if you're over approximating, obviously your exact area is here. Okay. And where will your trapezoidal sum be? To the left of the exact or to the right of the exact? It's going to be to the left. Your trapezoidal sum is going to be very close to the exact. Right? So what's your answer? First comes left, then trapezoidal, then the exact area, then the right. That's the order. Are we good? So which is the answer? Are we good? So your answer is B. Does that make sense?
Wait a second, Sal. Let me see.
Remember,
Okay.
the left Riemann sum gives under approximation. So you're going to be far away from the exact. The right Riemann sum gives over approximation. So you're going to be far away. You're going to be further up. So left and right are the endpoints. The exact is somewhere around here. So the trapezoidal sum is very close to the exact. Now, because this is increasing, it's concave down. Can you see? This function is concave down, right?
Okay.
It's increasing and concave down. As a result, is to the left. You can have increasing and concave up. See? Then it's different. Then it's going to be to the right in the trapezoidal sum, probably. Anyways, let's take this out. we still remember there is other ways of calculating this. You could have calculated by putting values and check what's the left Riemann sum, what's the exact area, what's the right Riemann sum. But remember, no calculators are allowed, so it's going to take you long to do this. You'll still come to the same answer by using numerical values. Okay.
Okay, so yeah, like this better.
Yeah. Next one. Next question, the graph of the piecewise linear function f is shown above. What is the value from 0 to 12 of f prime x dx? I think we have done this. This is just fundamental theorem of calculus, which is f of 12 minus f of 0.
Exactly.
What's f of 12? -4. What's f of 0? 4. So -8. Some questions are easy, some of them you got to think. The function f has a continuous derivative. F of 0 is 1, f of 2 is 5. 0 to 2 of f of x dx is 7. What is x times f prime x dx? You can evaluate this. Because the derivative is inside and we're multiplying by x, remember the function we don't know. So we're going to probably use the integration by parts formula, use the DI method. Let's not use that method. Let's just say let u equal to x. Because we can integrate, we can differentiate x and we can integrate f prime x. So what's du equals to? Dx. So we are using this formula here. Integral of u dv is equal to uv minus integral v du. What is u? Equal to x. What's dv equal to? F prime x dx. Okay. So what is v equal to? If you integrate this, you'll get f of x. Right. So what's the formula? uv minus v du. So the integral is uv. What is uv? X f of x. But I think we are evaluating the integral between 0 and 2. Don't forget that line because it's the exact integral. Minus integral of v du. What is v? V is f of x. And what's du? Dx. And that is still between 0 and 2. Okay, so what I've done is this is uv minus integral v du. Are we good?
Okay, yeah.
Now, what is 2? If you put 2 here, 2 times f of 2. 2 times what's f of 2? F of 2 is 5.
5.
Right? And 0 times f of 0 is 0. Subtract. What's integral 0 to 2 of f of x dx? They gave us that is 7. So what's 10 minus 7? 3. I'll say Z. Are we good?
Wait a
Does that
minute,
make
sir.
sense?
From 2 to 0, it will become like f minus 1, no? Oh, no, wait.
They gave us this integral already. You don't need to integrate this.
They give it. Okay, that makes sense. Yeah.
There's nothing to evaluate here. That is
Nice,
already
yeah,
given.
yeah.
That value is 7. So that's it done. Right. So now next one. Which of the following series are conditionally convergent? Conditionally convergent. Let's look at the first one. To check for convergence for the first one, we can just say this is, let's apply the ratio test to check whether it's because it has a factorial in there. And you know, most of the question that has factorials, we always use the ratio test. So if I use an plus 1 over an plus 1 is just basically, don't worry about -1, we're taking absolute value, so we're going to throw the -1 out. So it's just going to be 1 over n plus 1 factorial divided by, so it's just going to be n factorial, isn't it? Because you're going to flip this, because you're dividing by am. Make sense? Now,
Yeah.
n factorial,
Nice.
right. So now that's n factorial. Now, remember n factorial, I will leave as it is, and the bottom will become n plus 1 times n factorial, absolute value. Now, n factorial cancel out. Now, limit as n approaches infinity will give you 0. 0 is clearly less than 1, so it converges, absolutely convergent. It is absolutely convergent. You know that it is guaranteed for sure that it convergence. Convergent, okay? But they ask for conditional convergence, right? So now how we're going to do conditional convergence is by checking for alternatives, right? So let's see, -1 to the power n. Let's convert this. You see, root n, you can see root n. We can say this is P series because this can be written as 1 over n to the power, it can be written as -1 to the power n. I'm talking about an, right? N to the power half. So this is P series, okay? And P series with P equals half, so it diverges, okay? If P equals half, it diverges. Yeah, it does diverge. -1 to the power n, absolute of n. Okay, first the series is alternating. We can use the alternating series test, okay? I'm gonna check for that. Just a second. This here diverges.
But is it absolutely divergent, sir? Yeah, I
No,
think so, yeah.
no. There's no absolutely. We talk about absolute convergence, which is the first one, right? Now this here diverges, but we want to look for conditional convergence. So now let's check for the second one. We're gonna check for. We know that it's basically absolute. We took the absolute of an, so it's basically 1 over. So this part is P series, it diverges because it lies between 0 and 1. What about this one? P series, P equals half, it diverges. That's correct. What test can we use? Can we check for conditional convergence? We can check for alternating series test as well. So okay, we know that this diverges. We know that this also diverges. If you take absolute of n, okay, let's look for the alternating series test. Because you see that's alternating. If you can find convergence by using alternating series test, then maybe we'll know whether if it's conditional convergence. We can see it diverges. Conditional convergence means some terms converge, like it eventually converges. Right? So let's look at this second one. So it's alternating series. Option 1 is alternating series. Alternating series. So alternating series. Second condition we need to check is limit as n approaches infinity of absolute of an is equal to 0. Is it equal to 0? Yes, because if I substitute infinity, we're going to get 1 over infinity, which is 0, isn't it? And the third condition
exactly,
that we need to check, for the third condition we need to check is check if it's decreasing functions, okay? So square root of n an is an greater than an plus 1. Let's check. Is 1 over the square root of n greater than 1 over the square root of n plus 1? Yes, it is. Because you have a substitute, so it is decreasing. Right? Afterwards, you remember we had diverges, but now using the alternating series test, we can say, so this is basically conditional convergent. Next one, third one, which is this one over here. We're going to do a similar thing. It's alternating, so it satisfies the first two conditions. condition 1 is satisfies. Condition 2 is satisfies. If I say a n is equal to 0, infinity at the bottom. Condition 3, I need to check. Is a n greater than a n plus 1 for decreasing, okay? Decreasing for all values of n greater than 1. Let's see. So we got 1 over n plus 2 plus 1 is n plus 3. Is it greater? No. 1 over n plus 2. 1 over n plus 2 is clearly greater than 1 over n plus 3, isn't? This is definitely greater. It's like saying substitute 1, that's 1/3. If you substitute 1 here, is quarter. So 1/3 is, so conditional convergence. Are we good? So the last two, C. Make sense? The ones with the factorial, remember it will become an absolute convergence. Next one. Let R be the region in the first quadrant bounded by the graphs of y equals this x-axis and the vertical line x equals to 10. So that's your region, okay? One second. That's your entire region. And we know what the square root function looks like. So it's going like this, but it's bounded by some lines. Really, it starts at 1, okay? Because your x-intercept is 1, it starts at 1. And it's a root function. And 10 is somewhere around here. Right now, but because they said it's bounded by these lines, there's a bounded lines here. So this is x equals 10. That's 1. What's a point on top? The point on top, if it's 10, then it's 3. So 10 and 3. Now it's rotated about the y-axis. So you will get an image like this. Right? 1 second. Just to make it a little bit more symmetrical. Right?
Again, how did it take 3 said? Can you explain again?
What is that?
How if the position is at 10, how y becomes 3?
Okay, we substituted 10 inside this function here. 10 minus 1 equals 3.
Okay, yeah.
The y value.
9, yeah, root of 9,
Yeah.
3. Nice, thank you.
So now remember you're forming a solid, so your solid looks like this, okay? 1 second. So basically if you cut out a piece of solid, this is the inner function and that's the outer function. So you need to find the cross-sectional area. So for the inner and the outer function. And we just integrate that. And it's horizontal, right? The radius. So from the center of the y-axis to the endpoint, that's your R. Right, so you remember you're finding the washer method here. Right, and your inner function. So this is your x value. If you're going horizontally from here to there, that's 10. Okay. And if you're going from here to there, that's your inner function. Your inner function is this. So you basically, because your cross section is, you're going in a horizontal method, you're going to say area is equal to pi r squared, big R minus pi small r squared. Right, so this is outer and that's inner. So you've got pi, you can take that out as a common factor. What's r outer? 10. That distance is 10. So 10 squared minus, what's r inner function? R inner is y is equal to root x minus 1. But remember, we're solving for x because we're going horizontal. Okay. So if you're going horizontal, you're solving for x. So if you're solving for x, you can say y squared plus 1 is equal to x. If you take this square both sides, take the 1 over, you're going to get this. Okay. Now, so 10 squared minus y squared plus 1 all squared. Right. And your area is in terms of y. See, it's a function in y. So your area will be your volume, sorry. You're integrating the cross-sectional area. So your volume will be integral of all of this, integral of area dy. So which one is it? Oh, yes. And between what boundaries are you integrating? You're integrating over y boundaries. So you're integrating from 0 to 3. 0 to 3. Okay. So it's option D. Make sense? Are you good? 10 squared is 100. And it's y squared plus 1 all squared. Yeah. So you can go over that topic on, we did it in AB and BC course, application of integration application, volume is equal to that. Yeah. So no, not this one. Lesson number 25. Yeah. Disk method, washer method, we're integrating over different boundaries. See? Volume. So if you go here, this is about x-axis. So is dx. X-axis, yes. See, we integrate, we are rotating about y-axis, so it will be dy. Okay, so you can go over lesson number 25 for that. Right, so anyways, let's continue with our questions. I think we got 2 more questions left. Dx dt is 5, dy dt is sine t squared. Then what is d squared y over dx squared? First find what is dy dx. Because you're finding the double derivative. What is dy dx? Dy dx is dy dt over dx dt, isn't? What is dy dt? Dy dt is sine t squared, correct? And what is dx dt? Dx dt is 5. So just find the derivative of this. You find the double derivative. So that's d squared y over dx squared. So if you find the derivative of this function, don't apply quotient rule now. It's easy, right? Find the derivative of this function, then it's a function in t. dy dt. Ah, okay. Okay, one second. We have to apply the quotient rule because they got functions in t and stuff, right? So remember, let's call this y prime and let's call this x prime, right? This here is equal to y prime and let's call this x prime. Are we good? Y prime is a function in t, x prime is a function in t. Are we good? Hello?
Okay.
So now, so what's d squared y over dx squared? So you're finding double derivative. So this y double derivative, x prime, subtract, we are applying the quotient rule. So differentiate the bottom, x double derivative y prime over x prime squared. Now let's find what is, this is already x prime. X prime is 5, okay? So what's x double prime? 0.
0.
Yeah. Y prime.
So we can cancel out
is,
the right side, yeah?
Yeah. So x double prime is 0. So this part here cancels out. Now, let's look at this. What is y prime? Y prime is sine t squared, okay? So what's y double prime? Cos
T cosine t squared.
2t, cos t squared times 2t.
2t, yeah. My bad, yeah.
So what's y double prime? 2t cosine t squared. What's x prime? 5 over, what's x prime? 5, which is 25. So what's the answer? 5 and 25 can cancel out.
So B1, sir.
What's the answer? B.
B,
2t
yeah.
cos t squared. Yeah. 2t cos t squared over 5. Y double prime is cos t squared times 2t. T cos t squared times 5. X prime is 5 over 25. Yes. Right. Let's move on to the next question. We just have 2 more questions left. Then we're done. Question number 29. was just thinking, you know, previously we wrote down dy dx. What's dy dx? Dy dx was dy dt over dx dt. What is dy dt? Dy dt was sine t squared, and dx dt was 5. If we just find the derivative of this, then we kind of like finding the double derivative. So if I find d squared y over dx squared is equal to, find the derivative of this, this is because t squared times 2t over 5. Cos t squared 2t over 5. Getting the same answer. So the answer is B again. Is it?
Oh, yeah.
Both ways I got the same answer. Yeah. Okay, so we'll stick with this answer here. That's fine. Because I applied the quotient rule, I got the same answer. I've just went and applied the same, that 1 over 5 I can take out, I just differentiate the top. This is like just a constant. This is just a constant, not apply quotient rule. Take the 1 over 5 out. Just differentiate the top. 1 over 5. Just differentiate this sine t squared. So I'm getting the same answer in both cases, right? So great. Let's move on to question number 29. Which of the following expression is equal to? Right. So now remember the Riemann sum formula, right? So the Riemann sum formula is sigma. Limit. Limit as n approaches infinity of sigma I equals 1 to n of delta x, which is a width, times f of xi. Remember what is xi? A plus I delta x. So it's A plus I delta x. Delta x is given by B minus A over N, okay? Which is a width, correct? Delta x is the width. So now we need to know what is the width here. You see this 1 over N, this value here. This value of 1 over N that gives us the width. Makes sense? So we know delta x is 1 over N, which is B minus A over N. So the N can cancel out. So now we know what is B minus A. B minus A is equal to 1. Now we need to figure out, in the function itself, we got 2 plus 1 over N, 2 plus 2 over N, 2 plus 3 over N. So that is the A plus I delta x. So A plus I delta x is, A plus I delta x is basically equals to 2 plus 2 plus A plus I delta x is equal to no, we need to check which function it is. So I'm assuming a function of this form, 1 over x plus 2. Let's check. So if I substitute f of A plus I delta x, f of I plus I delta x, I is 1. So this is your first term, right? This is for I equals 1. So A plus delta x, basically, A plus delta x is equal to, substituting it into the function in the place of x. Yeah, I'm substituting this in the place of x, right? F of A plus I delta x, I'm substituting it in the place of x in the function. So it's going to be plus 2 here, and that's equals to 1 over 2 plus 1 over n. Now we need to do comparison. We need to compare here now. See, the constants is 2 and a. Okay, and you're going to compare it with 2. So you say a plus 2 is equal to 2. This implies a is equal to 0. Now, if a is equal to 0, b is equal to 1. Right, so it has to be, integral has to be between 0 and 1. Integral is between 0 and 1, and the function is 1 over 2 plus x. That's a 1. Are we good? Are we good?
Just a second. Let me see. So, again, so how did I get 1 over a plus delta x plus 2?
Okay. See, what is, I said, let me check the function. The function is 1 over x plus 2. It has to be 1 over x plus 2 because it's 2 plus 2 plus 2. The only thing that's changing is that 1 over n, 2 over n. So it has to be 2 plus x. Right, so you see all of them go 2 plus x, 2 plus x, 2 plus x. So I assume the function is f of x, 1 over x plus 2. So if I'm finding f of a plus I delta x, all right, I'm choosing a value of I as 1. So I'm only taking the first term of here into account. See this first term? Putting it there. If I take the first term into account, then the value of I is equal to 1. So if the value of I is equal, I'm just substituting a plus delta x. If I'm substituting a plus delta x into the function here, into this function, a plus delta x into this function here, I'm going to get 1 over delta x, a plus delta x plus 2. See, I bracketed it.
Oh, okay, so it will
A plus
become 1 over
delta
2.
x plus 2. Yeah, so that's 1 over 2 plus 1 over n. Okay? Makes sense?
Yeah, then a plus 2 equals to 2.
Yes.
So
So a is 0 and b is 1. And that's the boundaries of your integral. Remember, because this here is equal to integral a to b of f of x dx. That's your Riemann sum. Make sense?
oh, yeah, I remind. Yeah,
Yeah.
nice.
So
Okay.
so from 0 to 1 of 1 over 2 plus x dx. That's your Riemann sum. All right, next question, last question. A function f has a Maclaurin series given by this, and the Maclaurin series converges. So what is this? This is the f function, okay? And the Maclaurin series converges to f of x for all real numbers x. If g is a function defined by g of x is equal to e to the power f of x, what is the coefficient of x squared in the Maclaurin series for g? Are we good?
Okay, let's see that.
We want the Maclaurin series for g, and we want the coefficient of x squared. Okay? Now, let's just think about the Maclaurin series for g of x. G of x Maclaurin series will be given like this. Or any function. Remember the function f of x. What is Maclaurin series? Maclaurin series for f of x is given by sigma n equals 0 to infinity f prime, f nth derivative evaluated at 0 over n factorial. That's a Maclaurin series, x to the power n. Make sense?
Okay.
Now, if you want the coefficient of x squared, you're going to have the second derivative evaluated at 0 over, but you want the g for g of x. So g of x, if you want x squared, this means the coefficient we are looking for is g double prime 0 over 2 factorial. That's a term we're looking for. So we are looking for this answer over here. Are we good?
Oh, yeah.
Yeah.
For the second term. Yes.
Yes. Coefficient of x squared. That's it. So now what is g of x? G of x is e to the power f. I'm just putting e to the power f, all right? What is g prime? Is e to the power f times f prime. What's g double prime? Because we can find g double prime evaluated at 0. Is e to the power f. I'm doing quotient rule, I'm doing a product rule here. Differentiating e to the power f times f prime times f prime. Left the f prime. Differentiate f prime, you get f double prime, leave that e to the power f. Are we good?
Yeah.
Right, so now we need to evaluate everything at 0. What is g of 0? It's e to
1.
the power f of 0. No, g of 0 is e to the power f of 0.
Oh, f of 0 is 2. Oh, no, wait.
Wait. Yeah, you are right. F of 0 is 2. So remember, this is f of 0. This is f prime 0. This is f double prime 0 over 2 factorial. Make sense? So
Oh, yeah.
let's see.
4 to factorial, yes.
Yeah, so let's see. E to the power g of 0 is 2. That is correct because that's e. No. G of 0 is e to the power f of 0. So it's e squared. Are we good?
Yeah, e square, yeah.
Yeah. Next one.
Because it's the power of, yeah, nice.
This is e squared. Now we're finding g, everything evaluated as 0 now. Now we're finding what is f prime 0. E to the power f of 0. So we're finding g prime 0 now, okay? Now we are finding g prime 0. G prime 0 is e squared times, what's f prime 0? F prime 0 is 3. Okay. Now we're going to evaluate g double prime. So let's try to factor this out. So I can take out e to the power f as a common factor. I'm left with f prime squared. F prime squared plus f double prime. Yeah, plus f double prime. I want to factor it out. Now, I want to find g double prime 0. G double prime 0 is e to the power f, which is e to the e squared, correct?
Yeah.
Because I'm substituting that, right? So what's f prime? F prime is
3.
3. Yes. So we got 3 squared plus what's f double prime?
1 over 2.
F double prime 0. No. F double prime 0 over 2 factorial is equal to 1. So f double prime 0 is 2.
Oh, yeah.
So that is 2. Right? So now I've got 9 plus 2. E squared. 3 squared is, 9 plus 2 is 11, right? Right. E
Yeah,
squared
11.
11. And then we needed to find this coefficient. So over 2 factorial is just 2. So we just want g double prime 0, e squared 11 over 2. E squared 11 over 2. So the answer is D. I hope you understood everything. Are we good?
Yeah, x squared is just coefficient, yeah, because, nice.
Perfect. Wow. Yo. Right, so in part B, we have 15 questions. Graphing calculator is required, and there's 15 questions here. So let's have a look at question number 76. All right, so in question 76, what we have here is some function. Remember, there's a vertex here, so it's not differentiable at corners. The function f is continuous on the closed interval 0 to 5. The graph of f prime, the derivative of f is shown. Well, this is the derivative graph. I thought it was a graph of f. Anyways, the graph of f prime, it is continuous, so it's is shown above. On which of the following intervals is f increasing? F increasing, but this is f prime. So for f increasing, we need f prime greater than 0. In other words, above the x-axis. So where is it? Where's the function? Where's f prime above the x-axis? From 0 to 2 and 4 to 5. Are we good? So option D, easy. Make sense?
Yeah.
I mean, does this make sense? It's easy. From 0 to 2 and 4 to 5. That's your answer.
Yeah, simply, yeah.
Yeah, yes, easy. All right, so what they used was the term increasing. If they use the term increasing, sometimes they do this, they make it greater than or equal to 0. But if it's strictly increasing, then you can't include you can't include, you know, equal to 0. If it's strictly f prime greater than 0, this is called strictly increasing. So strictly increasing means you can't really include equal to signs, like 0 you can't include, 2 you can't include, and 4 you can't include. Okay, so you'll have round brackets. At the moment they said increasing, they are using the word loosely defined, so that's the reason why they have included 0, 2, 4, and 5. Okay, next one. So we got dy dt, which is 6e to the power this. By how much does y change? How much does y change as t changes from 1 to 6? So the y will change as y of 6. What's the change in y? It will be y of 6 minus y of 1. So if you want y of 6 minus y of 1, by the fundamental theorem of calculus, we can just say integral from 1 to 6 of y prime t dt. Are we good? And we have the derivative, which is dy dt. So you're just going to put it into the calculator and get an answer. Let's do it quickly. If you have a calculator, do this. The y prime t, you're just going to put it in terms of, you're going to put this entire function in y prime t. Quickly. Come on, guys, you should be fast with this. So integral. So we have the integral from 1 to 6, right, of 6. Oh, wait, you need to put brackets, make sure. 6 shift e to the power negative 0.08 alpha x minus 5 squared. And let me close the bracket there. Yeah. So 22.583. We're getting exact answer. So it has to be that. Okay. You understand? By how much does y change as t changes from 1 to 6? So it's y of 6 minus y of 1. And that, by the fundamental theorem of calculus, integral from 1 to 6 of y prime t dt is y of 6 minus y of 1. Substitute, right? You get a bigger function when you integrate. Next one. The function f has a property limit as x approaches 1 from the left is positive infinity. 1 from the left. So if you're approaching 1 from the left, there's the vertical line 1. 1 from the left is positive. So it can't be this because that's going towards negative infinity. 1 from the left, all right? Can you beat this one? 1 from the left is positive infinity. Yeah, great. 1 from the right is negative infinity. Okay. Limit as x approaches negative infinity is 2. Limit as x approaches negative infinity is on this side is 2. No, this is minus 2. So it can't be this. What about limit as 1 from the left is positive infinity. 1 from the right is negative infinity. Okay, it's going down. Limit as x approaches negative infinity is 2. Negative infinity is horizontal line 2, right? And x approaches infinity of f of x is 2, right? So that's correct. This is y equals 2, and this is x equals 1. And so again, 1 from the left is positive infinity, 1 from the right is negative infinity. Then, okay, let me put the 1 here. Put the 1 here. Right, so that's going towards positive infinity, that's negative infinity. As it approaches negative infinity, this value approaches 2, and positive infinity, this value approaches 2, which is correct. Here's it here. So it's option C. Right, so that's great. Next one. Tara's heart rate during a workout is modeled by the differentiable function h, where h of t is measured in beats per minute. H of t is measured in beats per minute, and t is measured in minutes from the start of the workout. Which of the following expression gives Tara's average heart rate from t equals 30 to t equals 6? So average value of function is equal to 1 over b minus a integral f of x dx from a to b. Now they're already telling us h of t, so you have to integrate h of t, right? So average value of function. Average value of function now in terms of this will be 1 over, yes, 60 minus 30. Come on, guys, try to solve the question. You can put your microphone on. From 30 to 60, f of x is h of t now in this case, h of t dt. So that's 1 over 30, 30 to 60, h of t dt. Not h prime t, okay? That's incorrect. That's your answer, B. Does that make sense? Are we good?
Yeah, makes sense. Yeah.
Yeah, straightforward. Obviously, if you integrate h of t here, you are going to get heart rate. But we want to find the average heart rate from 30 to 60, okay? If you integrate h of t dt, you'll get the heart rate because this is beats per minute. So you'll get beats, right? So you want over that interval. Next one. The function f has derivatives of all orders for all real numbers with f of 2, which is -1, f prime 2 is 4, f double prime 2 is 6, f triple prime 2 is 12, using third degree Taylor polynomial for f about x is equal to 2. When they say x is equal to 2, they mean c is equal to 2, okay? What is approximation of f 2.1? Right, so we know the f of x function, Taylor series expansion is n equals 0 to infinity, f nth derivative evaluated as c over n factorial into x minus c to the power n. So what we want p3, third degree is p3x. Third degree means to the power 3, x to the power 3. So what is the value of c? The value of c is 2. So 0th derivative evaluated as c is f of c,
12.
f of 2.
Oh, yeah, yeah.
F of 2 to the power 0. Power 0 is just 1, so take that out. F prime 2, x minus c. So in other words, x minus 2. Because that's over 1 factorial, I'm leaving that out. 0 factorial is 1. And 1 factorial is also 1. So I'm leaving that out. Plus f double derivative evaluated at 2 over 2 factorial, x minus 2 squared. And remember, Maclaurin series is when the value of c is 0. So you got to remember this formula. Plus we want the third degree, right? So f triple prime 2 over 3 factorial x minus 2 to the power 3. That's your third degree Taylor polynomial. Now you want to evaluate it at 2.1. So P3 evaluated at 2.1. What's f of 2? F of 2 is -1 plus what's f prime 2? 4. 2.1 minus 2, isn't? 2.1 minus 2 is 0.1.
Yes.
Plus
So 0.4.
F,
Okay.
you know, you're just going to put this whole thing in the calculator. Don't waste your time. Let's see the next one. F double prime 2 is 6. 6 divided by 2 is 3. 0.1 squared. F double prime 2 is 12. And 12 divided by 6 is 2. 0.1 cubed. Type this into the calculator and you should get some answer. Quickly. What's the answer there? I'm waiting.
A
Anyone?
second, please.
Yeah, please. Make fast.
0.532. Oh,
So
or maybe.
just make sure. Wait 1 second. Was it 2.1? Yeah, so 0.1, 0.1 squared, 0.1 cubed. This is correct. Not doing anything wrong
negative
here.
0.568.
You got an answer? Negative 0.568. Okay, great. So that's it, negative 0.568. Beautiful. So this is how you evaluate P3, okay? You got to learn this. This is Taylor and Maclaurin both, right? Because Taylor series centered at C, Maclaurin series just make the value of C 0. That's it. So you'll have an easier function for Maclaurin series. Everything is evaluated at 0, right? When I say f of 0 plus f prime 0, x, f prime 0 over 2 factorial, f double prime 0 over 2 factorial, x squared, that's Maclaurin series, right? Let's move on to the next function. Let f be the function with derivative given by this. What is the length? So arc length. What is the length of the graph of y equals f of x from x equals 0 to 1.5. Easy. Arc length formula is integral a to b square root 1 plus f prime squared dx. That's it. So what's your a and b? 0 to 1.5. Put into the calculator. 1 plus, what's f prime? F prime x is already given. That's nice. And we're squaring this. So great. That's just x cubed plus 1 dx. So it's like x cubed plus 2. It's fine. Just type it out. 2 plus x cubed. Give it the answer. You should get the exact answer here as well. Quickly. And see what answer you got for 81.
Plus 1, the brackets. I got 2.49748.
2.49. Yeah, so there,
Yeah.
B.
And
Great.
also, teacher, I think Sultan can't use his micro.
It's fine, it's fine, it's fine. He will understand. Right. Next one. Let H be a continuous function of X. Which of the following could be a slope field? Which could be a slope field for the differential equation of the form dy dx is equal to h of x. Now, it's very important to analyze what is h of x. It's only a function in x. Only function in x. Correct. So just assume that this is x squared. I'm just giving you an example, all right? What if we assume that this is x squared or negative x squared or anything? Then if we find the derivative, right? Sorry, not x squared. It's just a function in x. So if something is a function in x, example dy dx, if it's a function in x, maybe it can be x squared or it can be any function, man. Doesn't have to be x squared, right? Can be x cubed, can be negative x cubed, anything. I'm just looking at the parent functions. Now, this is already the derivative. In other words, if I change the y values, it doesn't matter. Isn't the at the x coordinate, the slopes will be the same? Example, if I substitute 1 and 2 inside here, does it make a difference whether if I substitute 1 and 2, or does it make a difference if I substitute 1 and 3? It doesn't, because you only care about the x value to be inside. Yes. So if you only care about the x value, look at the x value. At each x value, the slope needs to be the same. So let's look at the x value here. Choose any x value. So let me choose a positive x value. See, x value, like just say this is 1.
So D.
Wait. See, at the 1x value, is all the slopes the same? Yes. All the slopes are the same at x value 1. I'm just giving an example. Let's look at this here. The slopes are changing. So it can't be this answer. So this is wrong.
But you said all x's, huh?
Only x value, yeah. It can be
Yeah.
any y value. For any y value, the slopes at the x value will all be the same. So see, at different y values, the slopes are all changing here. So it can't be this answer. Let's look at this one here. We got changing slopes as well, using a vertical line. So can't be that. And over here too, it looks like slopes are changing. Yeah, the slopes are changing. See, this is positive, that's negative. So it can't be this, can't be that. So it can be option A. Okay. Make sense?
Yeah, so yeah.
Yeah.
Nice.
All right. Excellent. Sometimes they tell you to draw like a possible, they tell you to draw a possible graph that you see. If I'm looking at these slopes, I can see a graph is going like this. You know, they tell you to draw a possible graph of h of x. All right, so I've got an answer here. Possible, it looks like this graph is turning like this. See how it's going. Can you see?
Yeah, it's cubic, so
Yeah, so that's it. So this is a graph, this is a possible graph of h of x. Okay, not h of x, sorry. This is a this is a dy dx, so this is capital H of x because it's a bigger function. Slope fields is along the graph, what's happening to each of the slopes. So we can say this is a
capital H of X graph. It's a bigger function, okay? Because they usually tell you this is the derivative, right? So what's the possible graph that you can draw? Yeah. What's a possible, yeah, I would like to do some of this. What's a possible graph that you can draw here in the second example? The possible graph I can draw is, it looks like these lines are getting close here and is going out. And it looks like there's some kind of asymptote over there, but let's see. It looks like some graph is here. So, see how these graphs are turning, is going closer. Yeah, it's like all these, it's like these are some of the graphs that you can draw here. Can you see? And what's happening across this? Nothing. It's just everything is just like lines like this. So these are some of the, it looks like these are some form of like hyperbola graph. But anyways, you don't need to worry about it. You're not going to get a difficult one to draw. Okay, you got something that's identifiable pattern. All right, so anyways, we got an answer for this. Right, let's continue. We have lots of questions to solve. I think we did this in AB as well. This was easy. Right, let f be the function defined above where k is a positive constant. For what value of k, if any, is f continuous? For continuity, we need limit from the left equals limit from the right. So we're going to substitute 3 from the left, substitute the value of 3 in the left function. So you get k cubed plus 3 is equal to 16 over, substitute 3 in the right function, it's going to be k squared minus k squared minus 3. You're just substituting into x. So what you're doing is 3 from the left, and you need to write it out properly. What if it's a FRQ question? Then you need to write it out properly. You're going to say limit as x approaches 3 from the left of f of x is equal to limit as x approaches 3 from the right of f of x. Now you get this equation, solve for k. Just press shift solve on your calculator, right?
Oh, shift solve, yeah.
Yeah, just shift solve because you're allowed to use a calculator. Don't waste your time solving this equation. Because remember, calculators are allowed. Uh, 16 over alpha x squared minus.
2.081.
You getting an exact answer?
Yeah,
Wait.
2.081. You should press shift solve.
Shift solve. Yeah, 2 point. Yeah, perfect. 2.081. I think we did it with the AB guys as well.
Yeah, we did
Same
that.
same 2019 paper. Remember the common questions. Let's look at this one. Let f be a differentiable function. The figure above shows the graph of the line tangent to the graph of f at x is equal to 0. So at x is equal to 0, there's another graph which is tangent to this, okay? Make sense?
Okay.
All right, so now we need to check what happens at the tangent point. Just say this is a graph. I'm just giving you a general example. This is the graph of f, right? And let's just say this is the x, this is the y-axis. I will come to the y-axis part just now. So now what happens at this point? At this point, just say if this point, remember we were talking about x equals 0. Just say if this is 0 and any other y value, 0 and b, that's a point of contact, okay? So they told us the point of contact is right here. Now, what happens at the tangent point? We know f of 0 is equal to b, correct? F of 0 is equal to b. Make sense?
Okay.
Right. Now, how are you going to find the slope here? Slope of this line. To find the slope, you're going to say f prime 0. Okay?
Oh, okay.
Right. So now in this case, what is f of 0? This is the point of contact. If this is the point of contact is 0 and -2. So we know f of 0 is equal to -2. Are we good? Make sense? Now we're trying to get the tangent line here. The slope of this tangent. What is the slope of this tangent line? The slope of this tangent. No. How can the slope be 0? Slope 0 means horizontal line. I want to find the slope of this line here.
Ah, yeah.
So change in y over change in x is downsloping. Change in y
Negative.
is -2. Yes. Change in y, delta y, rise over run. Okay.
Rise over run. Yeah.
Yeah. So rise over run is just -2 over 1. The rise, well, the rise, there's no rise, there's a drop. So -2, right? No, sorry. The rise is +2 and the run is negative because I'm going in this direction, the triangle. So the rise is going up, rise and run. So it's -2. Okay. So the slope is -2 at the point 0. So now we got f prime 0 is also, that's how you find slope, is also equals to -2. So guess what? At that point, what's happening? The derivative and the functions are equal. Can you
Equal.
see? Yeah.
Yes, you
So
see.
the
But
answer
with
is C.
negative, just positive, yeah. Yeah, so
Yeah,
yeah,
so
C1.
but this is only a special scenario, okay? Not always. It doesn't happen in this case. Right, so I'm just giving you an example. We'll take this out. Let's focus on that only. Right, that's a graph. It's good. Next one. A referee moves along the straight path on the side of an athletic field. The velocity of the referee is given by the velocity, okay? So obviously velocity means he's moving in a certain direction of the referee is given by this function here, where t is measured in minutes, vt is measured in meters per minute. Meters per minute. What is the total distance traveled by the referee in meters from time t equals 2 to time equals 6? Very important. Distance, not displacement. Distance is equal to integral. This is distance.
Yes, not position.
Distance, yeah. Distance is d equals a to b absolute v of t dt. You're just going to put the whole thing on your calculator. And displacement is different. For displacement, there's no absolute. For displacement, then you got d is equal to integral a to b of v of t dt. Big difference, okay? So you're going to put this in your calculator now. Integral from 2 to 6, 4 t minus 6, don't forget the absolute, cos 2t plus 5, absolute value dt. Make sure you put the absolute values in the calculator. You don't put an absolute value, you'll get the wrong answer. Let's do it.
Where
This
is
is
absolute
nice.
values?
Yeah, I'm going to show you now. So you're going to go shift and there's apps. See that hype above the brackets? There's absolute value. So let's type the integral first and shift apps. So it's 4 open bracket alpha x minus 6 close bracket. Did you find the absolute value? Did you find the absolute value?
No, I didn't wait.
Shift apps, there's it here above the bracket. It says hype. It's written in gray on your calculator.
Yeah, my one
2,
is different. That's why.
okay, 2 to 6. And if I press equals, I'll get an answer. Why is it taking so long to compute? 21.667. See? Nice. All right, so straightforward. Make sure you have a calculator like this with the absolute value, please. Now, imagine if I took out the absolute value, what's going to happen? Then you're going to get a wrong answer, obviously. Now I took out the absolute value. See what answer you get. 3.93. And they even have that answer there. Look at that. That's displacement
Yeah, how
answer.
tricky is that? So, yeah.
Very tricky. So make sure you're using the right thing. Right, next question. The graph of the function f shown above consists of 3 line segments. Let h be the function defined by h of x. At what value of x does h attain its absolute maximum on the interval -4 to 3? Absolute maximum. How are you going to find absolute maximum? Absolute maximum is either endpoints or relative minimum and maximum values. It can occur there. So this is the graph of f, but we're finding at what value of x does h attains absolute maximum. H attaining absolute maximum on this interval basically means, what's H prime X? To find H prime X, it's going to become, substitute X there, so it'll become f of X. And if I make f of X equal to 0, it's either -2 or 0. I've got 2 points, or it can be the endpoints, -4 and 3. So I need to go and try to find some stuff there. So I'm going to draw a number line, and I will check where it attains the absolute maximum. So now I got -4, I got -2, I've got 0, and I've got 3. I need some answers now. Let's see. Obviously, from what if I find H prime X? What if okay, let's try to find the endpoints. What if I try to find H of 4, H of -4? Because I need the endpoints first. I need to know what the value is here and what the value is here. I need to know what's H of -4. H of -4 is 0 to -4 of f of t dt. So you can take out a negative and switch this integral around, take out a negative, switch the integral around. It becomes -4 to 0
Yeah.
of f of t dt. Now, -4 to 0, you can't evaluate from -4 to 0 because those are different. Actually, you can, because you can just find the area under the curve from -4 to 0. So you're basically evaluating all of this, right? You're evaluating from there to there. There's no absolute value, obviously. So the area under from -4 to -2 is half base times height. The height is 2. The base is 2, and half of that 2 times 2 is 4. The base, so that area is 2. Half of base is 2. Height is 1, so that is just 1. So because this is below and this is above, the net area will be, okay, let me see, negative. From -4 to -2 is what area? 2, but below the x-axis means -2. -2 to 0, what area? Is 1, isn't? Because I'm just finding area of triangle. It's going to become 1. It's just straight lines. So that answer becomes 1. So what's H of -4? The endpoint value is 1. Are we good? Now, next one we need to evaluate it. What is H of -2? Because I'm trying to find the absolute maximum, right? So H prime -2. Because when is f of x equal to 0? It's either -2, 0 or the endpoint. So now what's H of -2? 0 to -2, which is basically equals -0 to -2 to 0. Switching this around, taking a negative. So -2 to 0 of f of t dt. What's the answer for this? -2 to 0. -2 to 0, the answer is 1. Okay, so it's going to become -1. So I've got two values. This is -1. So far my absolute maximum is still at 1. Okay, because this is a smaller value. Let's evaluate at 0. What is H of 0? H of 0 is integral 0 to 0 of f of t dt. So that answer is just 0. Okay, so this is H of 0 is 0. What about 3? H of 3 is equal to integral 0 to 3 of f of t dt. 0 to 3. I want to find the area from 0 to 3. 0 to 3. Area under the curve, okay?
How are we gonna solve that?
Easy. And make a rectangle and make two triangles. Okay?
Oh,
Because
nice.
it's just straight lines. You're just finding area under the curve from 0 to 3. So what is this? Half base times height. This is 1.
2.
This
There
area
is
is 2. And this is half. Is that correct?
wait a second. Yeah, 1 times 1 over 2 times 1. Yeah, times 1. Yeah, 1 over 2.
So altogether you get 3.5. But below that, because it is below the x-axis, It's going to be negative 3.5. Okay.
Ah,
Be
okay.
careful. Yeah. So which one has the absolute maximum? At what x value is the absolute maximum?
At -4. Oh,
Perfect.
yeah, -4. Yes, yes.
At -4, the answer is 1. The rest of them, absolute minimum is at x equals 3. Right?
Yes, yeah,
Perfect.
you're right. Yeah.
And then relative minimum and maximum. Relative minimum is at 0 at the critical points. This is a relative minimum. Right. This is absolute max. This is absolute min. And this is, oh no, relative maximum. This is 0 and -1. This is minimum and maximum. So 0 is a relative
What's the difference
maximum.
between them?
Relative means critical points when the derivative is equal to 0, no endpoints. The word relative means no endpoints. Relative means the turning points. -1 is a relative minimum because you're comparing values. -1 is smaller than 0. So that's the relative maximum, relative minimum. Okay? Make sense?
Okay,
All right, great.
makes sense.
Question number 87. The position of a particle moving in the xy plane is given by the parametric equation x of t and y of t at time. What is the speed of the particle at time t is equal to 1.2? How do we
Oh,
find
teacher,
speed?
I saw that question when I was doing the practical exam from the college board. I saw exactly same question.
Yeah. You will find these types of questions everywhere. So how are we going to solve this? Speed is finding the derivative, right?
Exactly the derivative of the position.
Right. So speed is equal to square root of x prime t, x prime squared plus y prime t squared. That's it. That's your speed. Okay. And it's going to be evaluated at t equals 1.2. Right, so let's go. What's x prime? We got to work this out. Okay. Do we need to work this out? I'm just checking. ddx. Yeah, it's easier to just work it out. Okay. Let's see. What's x prime t?
Negative et, e to the power of negative t.
Negative e to the power negative t. Right? And we're going to evaluate it at t equals 1.2, and then we're going to square the answer. And what's y prime t? Y prime is here. Y prime t is equal to cos 4t, correct? Derivative of sine 4t, derivative of sine 4t is cos 4t, and the derivative of 4t is 4. Evaluated at t equals 1.2. Right? So obviously you're going to get this answer, so you're going to square it, you're going to get this answer, and you're going to square it and take square root of it. So I will do it like this rather. Actually, you can do this whole thing into the calculators here. It's the square root ddx, alpha ddx, shift ddx, e to the power negative t, e to the power negative alpha x, right? Evaluated at 1.2. Oh, we gotta square that as well. Gotta square
Oh,
this
I got the
answer.
answer, sir. I got the answer.
What-
0.461.
0 point?
0.4617.
Yeah.
0.4617. So yeah,
4.6.
this one.
Okay, so if you did this, then perfect. But remember, you still got a problem here because you got to square the answer. You have to find the derivative, evaluate it, and square that, and find the square
Yeah,
root.
I do the
Okay,
same thing, sir. Yeah.
right, perfect, excellent. So that just check up with that answer. It's easy. Let's just calculator work now. You get an answer here, and just square it. Next one. Let f be the function defined by f of x for how many values of x in the open interval? For how many values of x in the open interval 0 to 1.565 is the instantaneous rate of change equal to the average rate of change? So basically they're asking you f prime x is equal to what's average rate of change? F of b minus f of a over b minus a. So what's f prime x? X cubed, we're finding the derivative, 3 times 2/3, so minus 2x squared. Is that correct?
Yes, yeah, you're correct. Yeah.
Uh,
Oh wait,
yeah, it's right. It's right.
Yeah,
3
it's right,
times
yeah.
2/3 is -2. You are finding derivative, subtracting 1 from the power. So plus x minus a half. What is f of b? F of b is, you need to substitute the second value, okay? Inside the function f. F of b minus f of a. Oh man, you need to substitute f of 1.565, subtract f of 0. F of 0 will just give me 0 minus f of 0. That answer is just 0 divided by 1.565 minus 0. I just need this answer here. I need you to substitute 1.565 inside this function and give me that answer. And then after that,
Yes,
we can
okay.
do, yeah. So I'm going to cross multiply here. I'm going to get 1.565 x cubed minus 2x squared plus x.
Oh, I take really small number. Yeah, it's like -4.12
Wait,
times
wait, a-
times 10 to the power of
negative
-4.
negative 4.12 times 10 to the power negative. No. I need more decimal points. You can't tell me negative 4.12.
The calculator gave me like this answer, that's why I can't
No.
do anything. I know, just 0.000 -4 just.
Negative 4.12 times 10 to the power -4. Okay, we're going to take this and bring it over, add it up and make it equal to 0. So I'm going to put this in Desmos, okay? So when you put this in Desmos, you'll see how many roots does it have? How many times will it intersect the x-axis, right? We want to know how many solutions does this have? How many solutions are for x? So this is basically a cubic equation, and we're just trying to find the number of solutions. So 1.565. I'll make it into a function. Was 1.565, open bracket, x to the power 3, x to the power 3 plus x squared. Forgot what it was. Minus 2x squared. Minus 2x squared.
Plus x
Plus x
minus 1/2.
minus
0.5,
0.5.
yeah.
Okay. Plus 4.12 divided by 10,000. Okay. If I take this and bring it over, minus 2x squared, x cubed minus 2x squared plus x minus half minus 4.12 times 10 to the power -4. Man, I'm still confused about this. If you're substituting 1.565 inside here, why are you getting such a small answer? I'm substituting 1.565. Let me do it.
I do the same thing, so yeah.
Let's check.
Okay, I'll
One
check it. Okay.
1.565. Just bear with me, to the power 4. Minus 2/3 into 1.565 to the power 3, plus a half plus 0.5 into 1.565 to the power 2 minus 0.5 into 1.565. I'm getting 4.497. That's to the power 4 plus, yeah. Oh, no, maybe I made a mistake. That's a negative there. But still, negative 0.61356. 1.565 to the power 4 minus 2/3 x to the power 3 plus 0.5 x squared minus 0.5. Yes, be careful what you're typing here. So I'm getting negative 0.613. No, it's fine. Make mistakes. Obviously, we can't find an answer there. Right, so what we have, negative 0.61 3569. 3569. So I need to bring that over and add it up. So it becomes plus 0.61. Oh no. Plus 0.61. 569. But I'm bringing that over. 0.613569. 0.6135. So how many solutions do you have here? Solutions are x-intercepts 1, 2, 3. Are we good?
3, yeah.
Yeah, so what's the answer? 3.
Yeah, 1, 2, 3, yeah.
So there are 3 solutions. That's all they ask you for. They didn't ask you for the actual solution. They just asked you how many solutions are there. So you can see there's 3 solutions. And you can have a look at that function there. And what did I type in Desmos? Let me put that as well, so you know what to type. Right, so remember, I'm making the function equal to 0 because I'm bringing that over. So basically, I'm looking for x-intercepts 1, 2, 3. Nice. And if they ask you, remember the question can also be changed and they can ask you for a possible x value. So you can check. And they tell you the x value is between some interval. So anyways, let's move on to the next one. The population P of rabbits on a small island grows at a rate that is jointly proportional to the size of the rabbit population and the difference between the rabbit population and carrying capacity. Because we are dealing with carrying capacity, the population models that we learned was dP dt is equal to Kp into 1 minus P over M, where M
yeah.
was a carrying capacity. That's what we learned, carrying capacity. And we said the inflection point was M over 2. It occurs at M over 2. Now, we are looking at a possible model for this. So obviously we need to look at a model of this form. Carrying capacity. Now, you can see everything. There's nothing over M and stuff here. It's definitely not 1 over P. This is incorrect. If you're writing 1 over P here, that's incorrect because 1 over P times 2,400, 2,400 over P, that's minus 1. So this model is incorrect. This model only has, wait, let's start from the beginning. It can't be this model because it doesn't have, it's got a
K.
KP. Yeah, it doesn't have a P there. No, this model is totally wrong. This is like a linear model, this. We need like a quadratic model, see? If you multiply KP times P, you get KP squared, right? So we don't want this. So this is also incorrect.
So B1 also incorrect in that case.
B will also be incorrect because there's no P outside. So you're only left with one option. But let me show you how to get that option now. See, if you modify this equation, dP dt is equal to K times P into 1 minus, no, let's modify this. Then obviously this is 1 over 1, right? That's 1 over 1. So if this is 1 over 1, then it become M minus P over M, okay? And you can make another constant with K over, see this over M. This, remember, K is just a constant. K is just an element of real numbers. It's just a constant. So now if I take this M out, I will get K over M times P into M minus P. So you see M minus P appears here. So this is the carrying capacity, which is 2,400, right? And this one here, you can just make like another K, K2P into 2,400 minus P. So this is correct. Right? That's a population model. You can have a look at the lesson that we did on this topic here, which is on application of, I've done it somewhere, integration techniques, integration application. Yeah, differentiation apply logistic equation. That's what it was, right? See, it has to be a quadratic. It can't be linear. Right, anyways, let's go back here to our paper. We are almost by the last question. Yeah, last question. A region R is bounded by two concentric circles. Concentric circles are circles within each other, right? They share the same center. As shown by the shaded region in the figure above, the radius of the outer circle is R and increasing at a constant rate of 2 inches per second. The radius of the inner circle is R and decreasing at a constant rate of 1 inch per second. So this question is on related rates. It can come out in AB as well. It's a basic question. In square inches per second. What is the rate of change in square inches per second? So they're asking for the rate of change of the area region at the instant when R is 4 and R is 3 inches. This here is at the end. First, you need to find the area of the region. What's the area of the shaded region? What's the area of the shaded region? Pi capital R squared minus pi small r squared. Now find the derivative. Find dA dt. What's dA dt? dA dt is equal to pi 2 pi r, right? 2 pi r. And r is a function in time. So dr dt minus 2 pi r small dr dt, because small r is also a function in time, because they're giving you. Now read the question and substitute everything. Easy. So you got 2 pi, you can take out as a common factor. Okay, let's not take it out. Leave it like that, it's fine. You got 2 pi. What is r? R is 4. What is dr dt? The radius of the outer circle R is increasing at a constant rate of 2 inches per second. Increasing is positive 2. Subtract 2 pi. What's small r? 3. And what they said about the second one? The radius of the inner circle decreasing. Decreasing is negative. So negative 1. So what's your answer? That's 8. You can take out 2 pi as a common factor. So you're left with 8. Take out 2 pi as a common factor. You're left with minus 3 plus 3. So 11 times 2 is 22 pi. Are we good?
Nice. So D1.
Yes. And that brings us to the end of the lesson. I hope you guys understood everything. Any questions?
No, so are we done?
Yeah, we're done with the questions. We did the whole FRQ today. It's great. It's flipping taking us so long, man. 3 hours to complete the thing.
Yeah.
But obviously, if you guys remember everything, you'll solve it much faster. It's just that I have to do explanation. So I'm killing time like per question 5 minutes. Remember,